Hi, and welcome to this video from the data presentation side of the statistics course from year 1. And in this video we're going to move on to a different type of diagram, one you should be pretty much familiar with from GCSE, and that's scatter diagrams. And what we're going to do in this video is just kind of nudge your understanding of scatter graphs on just a little bit further. A lot of the requirement to calculate some extra stuff that we're going to be talking about got taken out of the course of the new specs, so invariably what you're going to be asked to do is be given some data and some figures, and you're going to be asked to actually do the interpreting part of it. There's much more emphasis on understanding what the numbers are telling us rather than physically being able to calculate the numbers. So here we go. So first things first, we are talking about bivariate data. So that means for any particular data value, or you've got two values. For example, if we were plotting, information about different people, we might be plotting height against weight for each individual person. We'd have one piece of value, a piece of data for their height, one piece of data for their weight. So that's why we're talking about bivariate data. So two quantitative values. In this one though, we're going to talk about values coming from a chemistry experiment. So what we've got is an experiment that's been conducted. So we've got a chemical reaction, and the yield of the chemical reaction, whatever's happening, is giving off a certain amount of stuff. I'm not a chemist, as you can probably tell. And what we've got is this reaction happening at different temperatures, and how much of this reaction is happening and how much is being yielded at those different temperatures. So what we've got is a couple of definitions that you do need to know about. And again, I have seen them pop up as questions asking you to describe which variable is which. So what we've got first of all is the independent or the explanatory variable, and that's always the one that is going to go on the x-axis on your scatter graph, and that's the one that you can control. So at this one, for example, you can see we've got a temperature along the bottom, and it might be that our researcher is measuring the yield at predetermined points that they are controlling. So I think on this one we've got a measurement when the temperature is 110, a measurement when the temperature is 115, a measurement when the temperature is 120. Those are entirely controllable, and what's that's causing is a reaction which is not controllable. That reaction is dependent on the temperature. So in this case we can clearly see the higher the temperature, the more yield we're getting. But those are the values that are happening at different intervals, whereas it's this one across the bottom, the temperature, that is the one that's controlled. So we've got this idea of independent or explanatory variable, or the dependent or the response variable. Explanatory variable along the x-axis, dependent or response variable on the y-axis. Okay, so what we can clearly see there is that as the temperature increases, the yield increases, so we can describe that as a positive correlation, and that's stuff that you should know about. And next year we'll look at exactly how that calculation does and how that determines what positive and negative, and look at that in a bit more detail. But for year 1, for now, it's just about saying that it's a positive correlation. As the temperature increases, yield increases. So there's our graph. Now, up till now, all we've done is just drawn a line of best fit by inspection. So basically what you've done is you put your ruler on your piece of paper, and you've tried to draw a line that's as close to as many of the points as you possibly can. We're going to move that on a little bit now, and what we've got is what's called a least squares regression line. This is what I mentioned at the start of the video when I said you used to have to be able to do the calculation of this one yourselves. Now you don't have to, it's given to you. And essentially what underlies it, basically what we're doing is calculating the vertical distance from each point to the line. So if we imagine putting a line of best fit through here, and then saying, okay, how far is that? Let's say that point there, how far is that from our line of best fit? And then we're kind of trying to minimize the sum of those differences, and that tells us mathematically where that line of best fit is going to go. And so we can get a line of best fit going on like that, and we've got an equation that's fitted to it. And again, the note there saying you don't have to interpret them. Sorry, you don't have to calculate them, but you will have to interpret them. So what we're going to do is have a look at what these figures in our line here mean. Something else to note is that our point is going to go through the x, or the average of the x and the y values, and as far as we're concerned in this course, it's always going to be a straight line equation, so it's in that form there. Y equals a plus bx, which is kind of the stats version of y equals mx plus c. Again, why there's a difference, I'm not entirely sure, but essentially what you've got is an intercept, in which case it's a, and a gradient, which is b. So we're going to have to look at kind of what those figures mean in this context. So here we go then. So the gradient. The gradient in this case is this 0.024 value, and the gradient is always going to measure a rate of change, and that's something you should be familiar with, hopefully from the pure side of the course. And essentially it's a rate of change when we're comparing to 1 unit increase in the independent variable. If you ask to describe it, you've got to make it contextual. So we're talking about, in this case, a 1 degree centigrade rise in temperature is going to cause a 0.024 gram increase in the yield. And so that's what that figure there means, that 0.024. So whenever you're describing it in any context, it's always a 1 unit increase in the x-axis that causes either an increase, or if the graph is going the other way, a negative correlation, a decrease in our dependent variable. The intercept is, in this particular context, is the amount of yield when the experiment is done at 0 degrees centigrade. This one you've got to be a little bit careful here, because what we've got in this one, you can see we've got this figure of minus 0.499, which doesn't make a whole lot of sense, because that's telling us that when we've got this reaction happening at 0 degrees, we're kind of destroying the yield, which again doesn't make any conceptual sense. You'll notice, again, be careful, we're not going to get our intercept just by drawing the sign and keeping it going back, because you'll notice my axes don't start at 0. So what we've got to do is be a bit careful with that one. And also, I would imagine that in this particular experiment, you can see the reaction is happening at temperatures above 100 degrees centigrade in this context. So I would imagine that at temperatures below 100 degrees, this reaction doesn't really happen. And again, that's another reason why in this particular experiment, the value of the intercept doesn't actually apply. But generally speaking, it's essentially what's happening when the independent variable is at 0. Now, last thing to mention is the strength of correlation is adjustment based on how close the points are to the line, not how steep the line is. That one is a common misconception from students, and what I'm going to do is just have a little fiddle around with this graph and just make it look a bit different just by changing the axes, not by doing anything to the data. So let's just have a look at this data in Excel. There we go, I'm in Excel now, and so what we've got here is the graph, and you can see now I have got it starting at 0, so all my data is in this top right hand corner, so we've got a bit of a presentation issue in terms of the fact that our data is all just shoved in this corner up here. What I'm going to do is just start off by making some changes to the scales on these axes. So let's have a look at what happens. At the moment, all my data is above 100, so what I'm going to do is change that value there to 100 and have a look at what that does to my data points. And straight away, you can see if I do that, all of a sudden it looks like the graph is much, much shallower. And so you might be thinking, okay, that's not quite as strong a reaction as we had, or stronger correlation as we had when it was looking like that. Because what we're talking about there is essentially the steepness of the line, but the steepness on our graph is just purely determined by what I'm doing to the axes, not what's going on with the data. So that's that one there. So let's just put that back to 0. By the same rationale, I can do exactly the same thing. Let's have a look at playing around with the figures on the y-axis. So again, instead of going from, in this case, a minus there, let's make it a minimum of 2. And all of a sudden, now we've got a very steep set of data. And again, you might be fooled into interpreting that very differently from what we were seeing when I had the axes starting at 0. So what I'm going to do is just get the graph looking as probably as best as I can by having both axes just at the same time. So let's change that value to 100 there. And there you go. What you've got now is a decent looking scatter graph with a clear positive correlation, and the whole graph is being used. I'm now going to add on my line of best fit. So in Excel it says add a trend line. Lots of different ones you can put on. We're always going to go for a linear one here. There it is. And the other thing I'm going to bang in is the equation of it. Let's just make that a bit bigger so you can see it. And there you go. There's the figures that I was referring to when I was working from the PowerPoint. And there we go. So the whole purpose of that last section was just about just being a little bit careful with axes, how something is being presented when you're talking about correlation.